Alright, in this video we're going to do some alkane nomenclature practice. So 4 problems that combine all the ideas we've looked at: cyclic alkanes, alkanes with multiple substituents, alkanes with complex substituents. So we're going to review all of that. And with the first example, the first thing I always do is identify the parent chain. So a couple different ways we could name this molecule. We could go straight across like that. That would give us 1, 2, 3, 4, 5, 6 carbons. Another route that my eyes see is coming straight down that way. Appears that would give me more carbons. That would give me 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons total. So that's definitely what we're going to want to choose as the parent chain. So let's highlight that here. So this is a 9-carbon parent chain. So 9-carbon parent chain is nonane. And it appears the only thing we have here is methyls. So a crazy looking molecule ends up being pretty simple. I have a methyl here, a methyl here, a methyl here, and 2 over here. Which way would I want to number it? Well, I would want to number it this way because I would encounter my first substituent at position 2 versus this way I would encounter the first substituent at position 3, and you always want the lowest number. So I would number 1, 2, 3, 4. Oops. 4, 5, 6, 7, 8, 9. So this molecule would simply be named 2, 2, 3, 6, 7, dash, and because we have 5 methyls, it's pentamethyl nonane. So I included all the positions of the 5 methyls. Penta for 5, methyl nonane. So 5 methyls on a 9-carbon chain at these positions. Okay, so that's our first example here. Not too bad. All right, so let's look at this one. And the first thing that my eyes are drawn to is the fact that this is a cyclic molecule. I know it's cyclic because I see this carbon ring here that has no start or end. So that's going to be our parent chain. Now this is a 4-carbon ring. 1, 2, 3, 4. So a 4-carbon ring is butane. Now remember that because it's a cyclic molecule, we add cyclo in the beginning. That implies that it's not regular butane. It's not a 4-carbon chain. It's a 4-carbon ring, and that's what the cyclo gives us. Now we have to deal with the things that are coming off of this 4-carbon ring. And I see a couple things. I see an ethyl group over here. I see a butyl group here, 1, 2, 3, 4 carbons, so a butyl group. And then over here, I see some kind of complex substituent. So here's how I want you to name these complex substituents. I want you to kind of think of them in their own box as their own molecule. And you always want to number the carbon directly attached to the parent chain, number 1. Now find the longest parent chain you can kind of create off of that carbon attached to the original parent chain over here. So the carbon directly attached to the parent chain is 1, and it appears that in any direction, the most carbons I can get is 2. So let's just make this the direction that we number. So it doesn't matter. So this would be the 2-carbon chain. So that's an ethyl group. And then at position 1, I have 2 methyls. So this would be named 1, 1 dash dimethyl ethyl. So the 1, 1 says that there's 2 methyls off of position 1. Di means 2 methyls, and it's ethyl because the longest chain is 2. So that's how we would name this complex substituent. It's also known as a tert-butyl group. And we always want to give, when possible, when numbering the chain, the highest priority to the complex substituent. So that would be number 1 here. And then we would just go in this order here. So remember that, let's label this. So this is a butyl group here because it's 4 carbons. This is an ethyl group here because it's 2 carbons. Now, kind of a little bit of a tricky thing here is that if you remember, we always alphabetize the complex substituents by the prefix. So that always wants to, that's how we would alphabetize these complex substituents, is by that prefix here. In this case, it would be alphabetized by the D in the dimethyl. So the first thing that's going to come first, actually, is the butyl group, because B comes first. So this would be starting off as 2-butyl. Next would come the complex substituent for being alphabetized by the D, not the M. So this would now be -1, -1, comma 1, dimethyl ethyl. I'll close the parentheses, add the last substituent, which is at position 3 and is an ethyl, dash ethyl cyclobutane. So one thing I want to point out is you notice that with the last substituent, it got tacked onto the cyclobutane, as it usually is, because this is the parent chain. So don't get confused by the cyclo part, it just tells you it's in a ring. So 2 telling us that we have a, 2-butyl telling us we have a butyl at position 2. The 1-1, comma 1 dimethyl ethyl tells us we have that a complex substituent, the 1, comma 1 dimethyl ethyl group, at position 1. And that's alphabetized by the D, so the B goes first, then the D and the dimethyl ethyl, and then the ethyl goes next, that's at position 3, and since it's the last substituent, it gets tacked on with the parent chain name, which in this case is cyclobutane. All right, so that's how we would tackle that one. I think that's a pretty good example. That combines a lot of different things. It combines the cyclic alkanes, it combines the complex substituents, so that's definitely a good question to keep on your radar. All right, so next we have this one. And listen, it can be overwhelming, but remember, the first thing you want to do is find that parent chain. So this one's a little bit difficult to find the parent chain because, you know, I actually have to think about how I would do this. So I'm first going to just look at left to right. That's definitely not going to be the most amount of carbons, but if I went that way, that would give me 6 carbons. I see another route we could take is maybe going up this way. Let's see that. So that's 1, 2, 3, 4, 5, 6, 7. Can I do better than 7? Well, let's try this. Let's try going down and around that way. 1, 2, 3, 4, 5, 6, 7, 8. All right, so that's the parent chain. It's the longest number of carbons, so let's highlight that. So it's kind of like, you know, a process and elimination thing. You want to try all the different routes and see which gives you the longest. So, you know, there's nobody who can magically look at it and say, like, that's the longest way. You got to think about it. So a couple things I notice. I have a methyl group over here. I have 2 methyls coming off of that carbon, and then I have 2 complex substituents. So this guy we just named, in the previous example, we named that as carbon 1 attached to the parent chain. We said that we could name that carbon 2 and make this the ethyl group, and then we have 2 methyls coming off of position 1. So this would be 1, 1 dimethyl ethyl, also known as tert-butyl. So we just looked at that guy in the last example. This one we haven't looked at yet. So we would number this rather as the carbon number 1 coming directly off the parent chain. Really only one way we could get a 2-carbon chain, either that way or that way. But both are symmetrical. I'll just choose that one in this example. So this would be the ethyl group, and I would have 1 methyl coming off of position 1. So this would be 1 methyl ethyl. So just 1 methyl instead of 2. And this is commonly known as an isopropyl group with its common name. So how would I want to number this? Well, it seems I want to number it going in this, in this direction, because I would encounter my first substituent at position 2 versus position 3. So I'm going to number it in that direction. So it would be 1, 2, 3, 4, 5. Oh, I'm missing a carbon. 1, 2, 3, 4, 5, 6, 7, 8, so 8 carbons, so that's octane. And now I have to look at the alphabetization. So remember, with the complex substituents, you always alphabetize by the prefix. So that's a D there. Can anything be to D? No. So the dimethyl ethyl will go first. So that will be 5-1,1 dimethyl ethyl. What would come next? Well, it seems that the methyls would come next, and we have a tie between the methyl in the complex substituent and then the regular methyls. So remember, the complex substituent will always win. So this will go first. So it would be dash 4-1 methyl. And now we will add the rest of the methyl. So it would be dash, and we have a methyl at 2, 3. We actually have 2 methyls at 3, and 6. Parent chain is octane, and there's 4 methyls, so tetra methyl, running out of room here, octane. So a little bit of a recap. This is a little bit of a tricky example. So this is probably one of the harder ones you would see. We identified this is the parent chain. It's 8 carbons. We saw we have 2 methyls coming off of that carbon, and then an additional 2 methyls. We saw that these were complex substituents, and we named this one again as 1,1 dimethyl ethyl, or tert-butyl. And we named this substituent here as 1-methyl ethyl, or isopropyl. When we do the alphabetization, the prefix is included, and that would win in this case. So the 5-1,1 dimethyl ethyl tells me I have this 1,1 dimethyl ethyl group off of carbon 5. Next, we would have a tie between the methyl in the complex substituent and the methyls just in general, the plain methyls, and the complex substituent always wins. So I put 4-1,1 methyl ethyl. Notice the dashes in between all of these. And then finally, and also the complex substituents in parentheses always. Then finally, I have 4 total methyls remaining. I have 2 coming off of position 3, 1 off of position 2, and 1 off of 6. So 2, 3, 3, 6 tells me the 4 methyls, tetramethyl, and it gets pumped onto the parent chain name, which is octane. So kind of a crazy looking name, but it is correct. So if you ever think your name is kind of too crazy, it probably isn't. So don't get worried about that. All right, I think I have one last example here. Yeah, our last example. And once again, my eyes are kind of drawn to the fact that we have a cyclic molecule here, a ring. So I always want to name that as the parent chain. In this case, it's a 6-carbon ring. So we would call this cyclohexane as the parent chain name. And now we got to deal with the substituents. So it's kind of clear that this is going to be some kind of complex substituent, but this appears to just be a regular methyl. We have 2 ethyls here, so let's deal with the complex substituent over here. So I'm going to number, as always, the carbon directly attached to the parent chain, carbon 1. And here it looks like I can actually get a 3-carbon chain. I could make this position 2 and this position 3, so that's 3 carbons. And then I have 2 methyls coming off of position 2 there. So this would be 2,2 dimethyl. And because it's a 3-carbon chain, it would be dimethylpropyl. So this is a different complex substituent we haven't seen. The common name is neopentyl. Nobody really calls that one this, so 2,2 dimethylpropyl is what we'll use. And it will obviously alphabetize by the D there. And then we have methyls and ethyls remaining. So the 2,2 dimethylpropyl will come first. So it would be, we haven't numbered the chain, my bad. So how would we number this parent chain? So this substituent will obviously get priority, and then we would go in this direction. So it would be 1, 2, 3, 4, 5, 6. So the complex substituent always gets position 1, and then we go in this direction because we encounter the substituents first. So this would be named 1-2,2-dimethyl propyl. I'll end the parentheses. Dash, now the ethyls will come first in the alphabet, so dash 2,3-diethyl. And now we will put the methyl at 5 and tack on the parent chain name. So 5-methyl-cyclohexane, because it's a ring. So we named the complex substituent, and then we should have numbered first. That was my bad. We numbered after, and we found that numbering the complex substituent number 1 and going in this direction after, they get the substituents at the lowest number. So this would leave that the 2,2-dimethyl-propyl is at position 1. So we start with that. 1-2,2-dimethyl-propyl tells us that we have that group at that position. Then we have 2,3 for the 2 ethyls, diethyl, because there's 2 ethyls, and then we're left with the methyl at position 5, so that would leave dash 5, methyl, and then we tack it onto the parent name, cyclohexane, because it's a 6-carbon ring. Cyclo tells us it's a ring. So I hope that you can kind of go back here and re-watch this if you need to and see how in each of these examples we followed the same steps. We identified the parent chain, we numbered it at some point, and then we would name any complex substituents by kind of thinking of them as their own molecule and finding the longest parent chain. All right, well, keep studying and good luck with nomenclature.